Okay, anyone that is not really into the finer points of electronics is probably hating this selection of videos now, but I'm really onto a breakthrough now with the linear regulator. The main board has not been changed at all. In fact, I'm about ready to remove that white clip lead and solder that link back through because it's not really needed. Here's my board from yesterday. Works, but it's probably not going to be part of the final system because I've got a new configuration that I've been thinking about, and it's proven to be very, very effective. So I'll give you kotanga. That's the Maori word for car radio aerial. Kotanga. Yes, this is literally a piece of coat hanger wire, well, a bit of steel wire. I believe it was from a coat hanger. It may not have been, but it probably was. It's kind of cool saying it was, at least. Now, we'll talk about it by, I think, first going back to this. This worked really well on the cloudy day. It was keeping the voltage up high to the regulator board, which meant that we were getting a realistic charge even on a cloudy day. That was good. But where it fell through was when the batteries were fairly well topped up. The day was sunny like it is today. There's Amon out there wandering around them. They've just been working on that little garden over there. And you want to put a heavy load on in the afternoon when the batteries are charged up, so you should expect all that load to come from the solar panel. Right. Well, I haven't had a chance to have the washing machine on this afternoon, which would be the ultimate test, but I did just boil the jug about 10 minutes ago. So we've got a sort of residual recharge left over from that. Now let's see if you can read that. There we go. Okay, 11.2 odd amps. And that's with my new system using kotanga. Now, to be fair, let's compare it to the encumbrance system that I'm ultimately replacing with all this jizz-jazz, okay? So, safety first. We'll disconnect the main feed to the regulator board, which, as you can see, now the current's basically nothing. And this green clip here is what's connected to the bases of the power transistors. And this red wire is from this voltage regulator IC and these jack-up diodes, which was my original system. As you can see, the base current now has dropped to nothing. So we're going to now connect to the old system. Okay, we're on the old system now. How many amps do we have here? And look at that, 9.2. It's alright, but not as good as 11. Actually, we won't see anything on that meter because it's not in the circuit, but that's not really the point. There we go, 8, 9, that's the old system. That's what's been running this for the last year or more. It's been alright. And now we click on to the new one, power it back on through the power of kotanga, and boom, boom, there we go, 13 amps. It's dropping rapidly, of course, because it just had the battery just had a bit of a rest. So it'll settle back down to its 11 point whatever it was doing before. So I had to make this video right now to show you that while the sun was up, while everything was good. Now I've got that out of the way, I'll explain what I've done here. Right. If you watch my previous videos and I've shown up on the top of this power transistor array, you'll see that there used to be a black wire from this terminal feeding up to here. A black wire, just blah, blah, blah. I was actually going to bring it in here and show it to you, but I forgot. So, oh, okay, it was one like this one here, alright, and it was from there to there. I've replaced that wire with, and I was always imagining I was going to replace it with something, but I never thought I would replace it with kotanga. Right. So, why have I done this? Okay. It's to create a voltage drop deliberately between the collector terminal of the power transistor array and the solar panels which come in over here, so therefore we can feed a couple of volts higher into the regulator board, which gives us more turn on voltage for these transistors. So this is one of those situations where less is more. Now I thought of it early on to, instead of connecting on the battery side, charge controller side of the diode, to connect on the solar panel side, which is the same thing on these ones, to give me a bit more drive, and that worked, but it didn't give me enough, so I'm doing that now. But that plus the voltage drop from this effectively low value high wattage resistor made of steel. It's not really a coat hanger now, it's a resistor, it's a power resistor, it's warm, I almost can't hold it, and that gives us a lot of juicy voltage drop, you see. In fact, I worked out the value so that when this was pulling about 20 amps through here, which was what the washing machine normally does, I'd be getting a volt of drop over this wire, which means it would be dissipating around about 20 volts. Now I think this resistor is slightly higher in value than my original calculations, but it's not critical. So what this does, it means that the collector is at a volt lower than here or here. These are both essentially the same, here or here, and this is about almost a volt higher too, because you get about a volt drop across these shock keys once there's a bit of current in them. So that means that this point here that feeds the regulator is always at that sort of current, about 2 volts higher than that point, which means that the transistor can be driven harder, and that's the key, and that's the key to it. That's what we were after all along. So, is this the final solution? Well, there's 3 main goals here. One was good performance on a cloudy day, good performance on the morning of a sunny day when the batteries are low, and good performance on a sunny afternoon when the batteries are charged up and you want to run a heavy load. Well, this definitely satisfies number 3 of those. It probably will satisfy number 2. Meter's moaning at me, it's going to switch off. But it doesn't solve number 1, whereas this original circuit here solves number 1 in spades. It's alright for number 2, but it poops out for number 3, so there we go. So maybe my final solution will be an amalgam of these 2 concepts, although this will probably be able to be vastly simplified, so we'll see. I did think of another approach, and that's to use a small extra solar panel to jack up the solar output to feed the regulator with. I don't know, I'm kind of liking coat hanger. I could put a wee loop around that, you know, I could put a wee loop around that connected through a buzzer to negative of the batteries and have a game of hot wire. In fact, it is actually hot. You could actually play it like this with your fingers if you touch the wire. Ow! Yeah, well, I'll probably, if I decide to stick with this, I'll probably put this on some nice former or something like that and run wires to it and make it look a bit more like a bought one. But you know, never ever run out and buy high value resistors. Just find the nearest piece of steel wire and there you go. Steel has a slight positive temperature coefficient though, so when it gets hotter its resistance increases a little. In many situations that's awesome, apart from, of course, if you're trying to make a shunt resistor, it's not so desirable there. But if you use a thick enough piece of steel, then that PTC effect is mitigated. And I'm basing the same principle on the emitter resistors, and they're made of steel guitar strings, so that they're quite thin, so they can get almost red hot at times, and the idea being that when they get hotter they do gain resistance and you know, resist better, which guarantees current sharing of those devices. So 10 minutes of ranting, eh? I hope that was kind of interesting. I'm as you can probably tell that I'm sounding a lot more buoyant than I was with the yesterday's bad weather day and stuff, so I'm going to go and have a cup of tea now, and I think we've just about cracked it. So roll these kind of ideas together, and then we'll be done. And when I'm done with this, then I get to do the coolest thing of all, which is to roll out the new batteries, which is something I've been kind of waiting for days, almost over a week now. So that's what we're really after with this exercise.